In Learning Target 5.9, this says that we can define a Bronsted Lowry acid and base. Now, what is a Bronsted Lowry acid and base is the key question here. So there are two definitions, one for acid and one for base. A Bronsted Lowry acid is something that donates a hydrogen ion, which you can think of as H+. Other synonyms for donate might be to give away or to lose an H+. A Bronsted Lowry base is something that accepts a hydrogen ion. And you can also think of synonym for accepts. That might be something that gains a hydrogen ion, or a Bronsted Lowry base accepts or gains or adds a hydrogen ion. Those all mean the same thing. So again, a Bronsted Lowry acid donates a hydrogen ion, and a Bronsted Lowry base accepts or gains an H. So in this example, we're going to scroll down here, and I'll do this one. And we need to identify out of our reactants what is the Bronsted Lowry acid, which I'm going to use red for, and what is the Bronsted Lowry base, which I will use blue for. So if we look at H3PO4, we see that on the reactant side it's H3PO4, and on the product side it looks similar except it's H2PO4. So because it lost or donated a hydrogen ion, and we know that it is the acid. And again, we know that it lost or donated because it started with 3 hydrogen atoms, and in the end it only had 2 hydrogen atoms. So it must have lost one or donated it. Now if you look at H2O, on the reactant side it's H2O, and on the product side it's H3O, which means that it went from 2 hydrogens to 3, so it must have accepted or gained, which means H2O is going to be our Bronsted Lowry base. And just to make this a little more clear, what actually happened is that the H3PO4 donated the hydrogen to H2O, so that it became H3O, and H3PO4 is now H2PO4. In this example, we'll do the same thing. So we look at H2O, and we see that on the product side it's HO or OH. So it went from having 2 to 1 hydrogen atoms, which means it lost or donated. And if you lose or donate a hydrogen ion, you are the Bronsted Lowry acid, which means N2H4 should be the base. Let's confirm that. We see that it started with 4 hydrogen atoms, and on the product side it's N2H5. So it gained a hydrogen ion, which is the characteristic of a Bronsted Lowry base. So this is true. N2H4 is the base. So I'm going to have you do these individual examples so you can pause. Label the Bronsted Lowry acid and base in the following reactions, and then resume the video when you are done. So PO43- is the base because it accepted a hydrogen, which we see over here. There was no hydrogen, now there is one. And H2O is the Bronsted Lowry acid because it ends up only having 1 H, so it must have donated that H to the PO43-. In the second example, HNO3 is the acid. It loses, which we can see over here. It loses its hydrogen, or donated it, so it's the acid. And H2O, it becomes H3O, so it must have gained the hydrogen ion, which is characteristic of a base. And it gained it from HNO3.